today we will see some questions in the last 2 years appeared questions from the IIT JEE. The question 1, the best method to prepare cyclohexene from cyclohexanol is by using, appeared in 2005. The options are given: concentrated HCl and zinc chloride, option B concentrated H3PO4, option C HBr, option D concentrated HCl. Actually, the cyclohexanol is an alcohol. What we are going to do is, we are going to remove a one H2O molecule to prepare the cyclohexene. So, this loss of water, generally we do the concentrated sulfuric acid at 170 degrees centigrade. You can also use alumina at 350 degrees. Dehydrating agents can be used, but this the first option, concentrated HCl and zinc chloride, happens to be a Lucas reagent which converts alcoholic function into the alkyl chloride. So, the option B is the right answer. Option C and the D also wrong. Option C is HBr makes the alcoholic function into the bromination, that is the alcohol converts into alkyl bromides. So, the option B is the right answer. So, let us go to the question number 2. When phenyl magnesium bromide reacts with tertiary butanol, the product would be, actually the RMGX reacts with the several the compounds which are containing reactive hydrogen, and they are going to give the alkanes. So, the first option, benzene, is the like that it is formed compound. Option B, phenol. So, it has a hydrogen and that reacts with the phenyl and also again gives the benzene only. Tertiary butyl benzene, wrong answer. Tertiary butyl phenyl ether is also wrong answer. Actually, RMGX adds to the carbonyl compounds and gives a variety of different types of the alcohols and all that. But here, phenyl magnesium bromide treated with the tertiary butyl alcohol, that is a active hydrogen containing alcohol. It does not going to make any other reaction excepting the H minus, the R minus and the H plus are going to react and liberates as a benzene. So, the benzene is formed. So, option A is the right answer, the other 3 are the wrong answers. So, therefore, answer A is the right. So, let us go to the question number 3. A phenol is treated with the ethyl iodide in presence of sodium salt or the ethoxide. Actually, it is a sodium salt of ethoxide is taken, and hydrous ethyl alcohol, a mixture of ethyl alcohol, that is a strong basic medium. The phenol is used. Phenol in the basic medium converts into the sodium salt of the phenol. Phenol converts into the sodium phenoxide, and then the ethyl iodide is used. So, phenoxide attacks on the ethyl iodide, it shows a nucleophilic substitution. The product is a phenyl and ethyl containing ether, that is option B is the right answer. Diethyl ether or the diphenyl ether are the wrong answers. Right answer is phenyl and ethyl. So, the phenol containing a strong base like ethyl group O will react with the hydrogen and it converts into a phenoxide. This results in the phenoxide formation. This phenoxide formation reacts in the ethyl iodide. It shows a nucleophilic substitution, and you will get a one side phenyl, one side ethyl containing compound is formed. This is a name reaction called Williamson synthesis reaction, in which one of the alcohol or phenol is converted into sodium salt, the other one is converted alcohol into the alkyl halides, then both are treated to get the ether instead of taking 2 alcohols and treating with sulfuric acid. This is the best method in terms of the purity and in terms of the quantity. The Williamson synthesis is proved to be the best method. So, answer goes to the answer B. So, let us go to the question number 4. The question is, in the reaction of phenol in basic medium, bromine is added. Actually, bromine and water is enough to brominate the phenol, but in basic medium specifically, a sodium salt of the phenoxide is formed. the phenoxide makes the ortho minus, para minus and ortho minus, on which bromination goes through the dibromo product is also formed. Therefore, the dibromo orthobromo dibromo product as well as monobromo product, and also the at the para position you getting a phenoxide like this structure is also one of the intermediate in the reaction. Here what is happening, the Br plus is released and this goes to attack as a Br plus in the next compound, a bromonium ion attacks in the other reaction. So therefore all the four, the A, B, C are right. So the answer D is, therefore it is the right answer. Answer D is the right answer. So let's go for the question number 5. The question goes like, the correct acidity order of the following is, it's a 2009 question. The two phenols are given, one is ordinary phenol and the second one is a chloro substituted phenol. The chlorine is a minus I group which increases the acidity of the phenol, so therefore chlorophenol is stronger than the phenol. And subsequently two compounds are, one is benzoic acid, the other one is benzoic acid with methyl. Methyl is a plus I and plus hyperconjugation decreases the acidity of the methyl group. So among the benzoic acids, benzoic acid is strong and methyl benzoic acid is weak. Among the phenols, chlorophenol is stronger and the ordinary phenol is weak. Now comparatively with the phenol and the benzoic acid, always benzoic acid is the stronger acid when compared with the phenol. A carboxylic acid, that is COOH, is a stronger one than the phenol. Actually, if you see the resonance structures of the phenol, phenol will have a phenoxide. If you remove the proton, it will have the 3 resonance structures. But if the carboxylate anion only minus, and that minus destabilizes between the, this O minus will give and the O minus. Only the 2 resonance structures, minus here, minus there. But the phenoxide anion has 3 resonance structures. We think that the phenol must be the stronger, the phenoxide is more stabilized. So therefore, we think phenoxide is more stable, therefore phenol must be the stronger. But here what happens, the CO is pulling and the O double O, that is minus charge, is donating. So it is a perfect resonance than this type of the charge distribution. So therefore carboxylic acids are stronger acids when compared with the phenols. So naturally phenol containing a chlorine is stronger. So among the 4 given is here, the phenol, that is benzoic acid, 3 is stronger than the 4. 3 is stronger than the 4. This is one order, and among the phenols, the 2 is stronger than the 1. So 3, 4, 2, 1 is the right answer. That is the answer A is the right answer. Let's go to the question number 6. The IUPAC name of the following compound, it's a 2009 question. The question is, there is a benzene containing the 3 functional groups. One is OH and one is a cyanide, the other one is a bromine. Now out of these 3, cyanide will be the important one. So let us call this compound as a benzene with cyanide is called benzonitrile. Cyanides are named as nitriles. So the benzene with the nitrile is called benzonitrile. And the numbering is also starts from the cyanide containing benzene is the 1. So therefore bromine is given 2 and hydroxy is given 5. So therefore it is alphabetically bromine, after that hydroxy comes. So therefore 2-bromo 5-hydroxy benzonitrile is the right name. So therefore answer will be the B therefore. So let's go for the question number 7. The question is, the correct stability order for the following species is, there are 4 different carbocations are given, and among these the order of the stability is asked here. It is the decreasing order, that is the most stable one. First we have to write. So here the species 1 is a carbocation containing a 3-degree carbocation attached with a lone pair. So therefore it is originally 3-degree, and as well as a sort of resonance is also coming. So therefore naturally this type of species will be the most stable one. Whereas if it is at second one, if you take it is a compound with the only 2-degree carbocation, it is, there is no other speciality. Just 2 degree means 2 plus I groups will be there, some 5 hyperconjugations are there, that's all. In the third one, once again we have a 2 degree carbocation containing the oxygen lone pair, can show a resonance type of the stability is also coming. In addition to the inductive effect, we have a resonance type of stability. On the oxygen we have a 2 lone pairs, so therefore these lone pairs will show this conjugation with this positive charge. The last one is very much similar, but it is a 1 degree carbocation. All are very closely related compounds. It is a carbon with a positive charge, and the last carbon means it is 1 degree. So therefore 2 are supported by the resonance type of phenomena, 2 are ordinary one. Out of these 2, 3 degrees more stable, followed by the 2 degree, then 2 degree, and then 1 degree. So therefore answer goes to the 1, 3, 2, 4. 1, 3, 2, 4 means the last one, that is the answer D is the right answer.